Hey everybody! Today we need to finish off section 8.2. On Friday we did this, so if you weren't in class on Friday before spring break, here's the rest of the lesson. Let me pull up the handout that I gave out. There were just two word problems that we want to cover that are going to come out of this section. All we worked on was using the quadratic formula to solve quadratic equations, and so we're going to use that. Let me actually start with the second word problem because it's a little more straightforward, and then we'll spend some time on the first word problem. So here's what we have. It says an object is thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second. The height above the ground, h of t, in feet of the object after t seconds is given by the function. Right, here's our function h of t. How long after the object is thrown will it take to hit the ground? Now, honestly, they give you a lot of information here, but all you really need is the function. These are the types that I claim aren't even word problems because you don't have to do any modeling or work hard to write the equation. It's given right to you. So let's go to our sketch pad and let's do this problem. So it says you throw something off of a top of a 200-foot cliff. How long will it take before it hits the ground? So all we're doing here, if you notice the shape of this, if I were to trace it back, it's just a quadratic or a parabola. We're looking for how long it will take to hit the bottom. Well, all we have is a function for height, right? H of t is equal to, let's see, what's that function? H of t is negative 16 t squared plus 12t plus 200. Well, this function tells us the height for whatever time we're at. I don't know what time we're at. That's actually what the question's looking for, but I know the height. The height, we're looking for when it hits the ground. What's the height when it hits the ground? That would be a height of 0, right? So h of t equal to 0. So I would just want to solve this for the time when it's equal to 0. Well, how awesome is this? This is exactly what we did the first half of the lesson, where we set our quadratic formulas. Notice this is quadratic because we have t squared. Set our quadratic formulas equal to 0 and plug them in to the quadratic equation. And we have our a, our b, and our c. So I can easily plug them into our formula. Remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So this is plug and chug math here. I know all these pieces. Now be careful because this is a negative 16 for a. And I can throw all these into the formula and find the time for when the height is 0. So let's do that. Let's see. So t equals opposite of b. So b is 12, so the opposite of b will be negative 12 plus or minus. So notice this is representing two answers at once. 12 squared minus 4 times a, which is negative 16, times c, which is 200, all divided by 2 times negative 16, 2 times a. Now, obviously, we'll do some of this in a calculator because some of this is not so easy to do in our heads. We could do pieces of it without too much stress here, right? Like, I think I can handle the 2 times negative 16. Let's see, 2 times negative 16 is negative 32. Yay, me. But for this part, underneath the radical here, I'm going to use a calculator to figure out what 12 squared minus 4 times negative 16 times 200 is. So let's see. I get some really large number. I get 12,944 just using my calculator. So now this is going to give me two answers. We're going to use a calculator to finish out these two answers here. So one of the answers is negative 12 plus the square root of 12,944, all divided by negative 32. And the other answer, the other possible solution, is negative 12 minus the square root of 12,944, all divided by negative 32. So once again, we're just going to use a calculator to do these to get the approximate solution. I don't think the square root of 12,944 is a perfect square, but you never know. You could try to give that a shot there, but I'm pretty sure it's not. Let's see. So negative 12 minus the square root of 12,499, all divided by negative 32. Now when you do this, you'll want to make sure that you put parentheses on top of this when you put it in your calculator. So when I put it in my calculator, I got negative 3.11. Right, awesome. Let's do the other one over here. So let's see. All of that, just the only difference is it's a subtraction right there. When I type this one in my calculator, I'll get 3.86. Let's go one more decimal place. 9. 3 decimal places. It doesn't really matter. I'll tell you on a test how many decimal places I want. So those are the two possible solutions, the time that it should take for this, whatever it was that we threw, baseball, stone, person, off the top of this cliff. It should take one of these two times for it to hit the ground. Now, this one's negative. Do we ever count time in negatives? And the answer for that's no. So I can get rid of that one. So this right here, now we probably want units on it. It was in seconds if you read the problem. So it takes, to answer the question, if I go back to the question, it takes 3.869 seconds for the object to hit the ground. Okay. So now let's look at the other word problem. The other word problem is a little more involved. So it says you live on a corner lot and people often cut across your yard to save time. Look at the diagram below and find the walking distance saved by cutting across your yard instead of walking around the sidewalk, around the edges. Okay. So you must be the grumpy old man now, not wanting people to cut across your yard. So notice one side is x plus 20, the other side is x. And where they're cutting across right through your grass is 50 feet. So let's draw this to get a little diagram over here in the corner. So this one's 50. This was x plus 20. And this was x. And this is a 90-degree angle. I should have had that in the other drawing, but I think I forgot it. So we want to see how much walking distance they save by cutting here as opposed to walking on the sidewalk. So you need to know if you need to be sitting on your front porch with a shotgun trying to menace them into not walking on your freshly mown grass. So let's see, how can I relate these values? Well, this is where you reach back into your high school days and remember the Pythagorean Theorem. And so remember the Pythagorean Theorem says you take one of the legs, one of the sides, square it, add it to the other leg, the other side, touching the 90-degree angle, and square that as well, and it will equal the long side, the hypotenuse, the side across from the 90-degree angle. It'll equal that squared. So just a little bit of algebra and I can clean this up. So x squared, that's just x squared. X plus 20 squared. Remember, you're going to have to FOIL that out, a little bit of scratch work. X plus 20 squared means x plus 20 times x plus 20, and you're going to have to FOIL that out. I'll be your calculator right now and save you some time. We'll call it x squared plus 40x plus 400 equals, now what's 50 squared? That'll be 2,500. Awesome. So let's see. Let's think about the question and see what we can do to answer it. The question says, hey, how much space are they saving by cutting here? So that means I need to find these distances to see how long it takes to walk around your yard as opposed to through it. That means I need to find x. I can solve for x here. Notice I have x squared, which means this is a quadratic equation, If I could get it equal to 0 by subtracting 2,500 over and combining some like terms, I could use the quadratic formula to solve this, to find what x is. So let's do that. If I combine these two like terms, that'll give me 2x squared plus 40x, and let's go ahead and subtract 2500 over. And that'll give us a negative 2100 equals 0. So there are our pieces, A, B, and C. Notice C is negative. Remember, the signs directly in front of a number belong to it. So we're going to plug them into our quadratic formula. So x equals opposite of b. B is 40, so the opposite would be negative 40, plus or minus the square root of b squared minus 4 times a times c, negative 2100. I'm going to extend my square root so they all fit. All divided by 2 times a. Once again, we'll want a calculator to handle this part right in here. So let me go ahead and figure that out. Let's see. In my calculator here. Clear everything out. So 40 squared minus 4 times 2 times negative 2100. Oh my. Alright, and let's see what I get. I get 18,400. So I'll have negative 40 plus or minus the square root of 18,400, all divided by, and I can handle 2 times 2 without a calculator. That's 4. So now I'm going to want to find both solutions. One will have the plus sign, one will have the minus sign. And let's see, let's get the approximate answers by using our calculator. Typing them in our calculator to see what we get. And so I want to type all this in. Remember, you'll probably want to carefully put parentheses on top of this fraction before you type it in your calculator to see what that solution will end up being. Now let me ask an important question while I write all this out. Do you really think there are going to be 2 possible answers for this? Or what's going to happen to one of these solutions? Think about that. Alright, let me type this in. So we'll go with negative 40 plus the square root of 18,400. 18,400 all divided by 4. And so I got 23.91. We'll just go 2 decimal places. 23.91. Now let's check this one out. So if we have negative 40 minus the square root of 18,400 all divided by 4, I will get some negative number, negative 43.91. Can distance be negative? The answer for that's no. We've answered that earlier in the equation, earlier in the semester. So whenever we do these, quadratics have 2 solutions, oftentimes 2 real solutions, not always, but 2 solutions, and one of them will be a bad one, what people call, well, an erroneous solution or an extra solution, but because we don't measure distance as negatives. Okay, so now I'm going to need some more paper, so help me remember that we got 23.91 is x. Okay, let me give my drawing here again. So x plus 20, x, and 50, and we have found that x equaled 23. What did we find it was? 23.91. All right, now awesome. So listen very carefully for a second. The question, if I go back and look, the question was, how much distance are they saving by cutting here? So I need to find this distance. Since I have x, wouldn't the distance be just adding these 2 sides together, these 2 pieces of sidewalk here? So yes, let's plug in x and add these 2 things together. So let's see, what's this side going to be? It's going to be x plus 20, which is 23.91 plus 20, since I know x, which is 43.91. Over here, I know x. What's x? This side will be 23.91. Obviously, my drawing is not to scale. Y'all know my drawings are always horrible. So what's the total distance? It's just going to be adding these two sides together. What is that going to give me? Well, that'll give me, let's see, 67.82, just doing it in my head. So that's the distance walking here. Now, once again, have we answered what they were asking for? Answered the question. The question was, how much distance are they saving? So what's the difference in cutting the corner here, which is 50, and walking around? Well, difference is a mathematical word that means subtract. So I could find the difference by just subtracting. So what's the difference? That would be 17.82 feet. So how much walking distance are they saving? They are saving 17.82 feet.